Section 6.3 is on page 400, talks about properties of logarithms. And here they call them properties. I really like to call them laws, but it's the same thing. And there are three of them. If you take the log of two terms multiplied, you could split them into addition. Think of it this way. Logs and exponentials go hand in hand because they're inverses. If you were taking exponentials and you were multiplying, wouldn't you add the powers? And what if you were dividing exponentials? Don't you subtract the powers? So when you look at the quotient, you would end up subtracting. And if you take exponentials and you raise the powers, don't you end up multiplying those? So if you see x raised to the r, you could take this power and multiply by it. This is one unique property that makes logs stand out from anything else. Of course, they're copying for log base 10, log base e, which is the same thing. So we want to adjust and start using those. So looking at problem number 2 on page 405, if I keep those in mind, I'm looking at, so I'm going to call this law 1, I'm going to call this law 2, and I'm going to call this law 3, and I'm going to refer to those as I do problems. If I look at problem number 2, I'm trying to simplify this. Well, the base is a 5. I'm going to write this as 1 over 125 to the 1/4. By the third law, I'm going to move that up front. And wouldn't you say this is 1 over 5 cubed? This moves up. You have a couple of options now, but let's stick with that for now. And those undo each other. And you're left with 1/4 of negative 3, which is negative 3/4. And there it is. So, same deal here. I can't really say log base 5 of, because that's under the radical. So I'm going to say this is 2 times a log base 5 of 125 to the 1/2 power. So if the argument is raised to a power, by the third law, I could move that up front and say that's twice 1/2 times the log base 5. And isn't 125 5 cubed? That is 2 times 1/2, and this is the second property of logs, not laws, previous section. That's a 3. And wouldn't that be just 3? So we must learn how to combine those and expand them accordingly. Number 8. Now here I did move this up. I have another option. I could also say, you know what, this is the log base 9 of 1 minus the log base 9 of 27 plus the log base 9 of 3. Log base 9 of 1 is 0. I'm going to rewrite those. You don't have to rewrite them. I'm putting them in that order so you could see by the second law of logs that this equal. By the second law of logs, this is 2 logs with a minus in between. I could write as a single log, and I could divide those 3 over 27. And you'll notice this will become the log base 9 of 1 over 3 divides 27 9 times. And again, either I could move this up, or I could say, you know what, that is log base 9 of 1 minus log of 9. That's a 0, and that's a 1, and I end up with a negative 1. 2 logs with a minus in between, I could write as a single log, and the order is very important. That's why I rewrote those and I put the minus after. Wherever the negative is in front, that's what goes in the denominator. So the 56 must really go in the denominator and an 8 at the top. This is not by choice. And 8 divides 56 7 times. Now here I did do the log of minus. Here I'm going to do it by saying move this up. So you have an option always with that property. And those undo each other and you're left with a negative 1. Or you could have said, if you want it, this is the log base 7 of 1 minus log base 7 of 7. That's a 0 minus and that's a 1. There it is. Next problem up is number 12. 12, we say, well, that's a log base 9 and a plus in between. You multiply 3/5 times 45. And that's log base 9. We know 5 divides 45 9 times. And that's a 27. And those don't match. Anytime that happens, anytime you look at a log and you say, you know what, it's not reducing, they said to evaluate with a calculator. If I call this A, if I let this equal A, and I get rid of the log, those undo each other. 27 equal 9 to the A. This is 3 cubed. And isn't 9 3 squared? Wouldn't you say 3 cubed equal 3? And if you raise the powers, don't you multiply those? 2A. Doesn't that mean that 3 must equal 2A? Right? If the bases are the same, the powers are equal. You could go to logs, and you'll get that if you log base 3 both sides. And A would be 3/2. Didn't I let A equal this? So that's my answer. This doesn't happen a lot, but whenever it happens, you could use set that equal to A and solve for A, and that works. Another problem, I see a plus and I see a minus. I could do this in steps. I'm going to do this 2 ways, or I could do it one shot. I could say this is log base 3 of 2 times 4 minus log base 3 of 72. I could say that's log base 3 of 8 divided by 72. And I know that 8 divides 72 9 times. And isn't that log base 3 of 1 minus log base 3? 9 is 3 squared. And wouldn't that be a 0 minus a 2, which is a negative 2? Now, if you really think about it, you could always do this. If this is a 1, assuming all of these are 1, I could say, one shot, I could say this is a log base 3, and this is how it works. Anything with a plus goes at the top, anything with a minus goes in the denominator. The top, 2, there's a plus times 4, times nothing left. If it's a minus, you divide, and you proceed the same way. Now, I'd like to look at number 20, and I'd like to apply that. Again, if all of these are 1s, of course, this must be a 1 or a negative 1. If you glance at these rules, there's a 1 there, there's a 1 there. So if you want to go back, it has to be 1s. If it's not 1, you would use the third law to make it a 1 by working this backwards, and then you proceed. So when I look at this problem, I could do this one shot. I could say, and look how it would look. If you do it a step at a time, log base 8, 2 logs with a minus, is 40 divided by 5, minus the log base 8 of 64. And this would be the log base 8. Isn't that 8 minus log base 8 of 64? 2 logs with a minus in between, you could say 8 divided by 64. And we know that 8 divides 64, 8 times. If I move this up, just like we did on the previous problems, I know this will be a negative 1. I could have done this one shot. Again, I highly recommend that. Write a single log, base 8. All the pluses at the top, that's a plus at the top. All the minuses on the denominator. 5 divides 80 8 times, and 8 divides 64 8 times. Move this up. That's a negative 1. I suggest you do that. Again, it takes a bit of practice, and you have plenty on the homework to practice if you need. What if I want to go the other way around? What if I want to expand those as much as possible? Well, first things first. I noticed that this is a log base 2 of 8x over x plus 1 raised to the 1/2. Third law of log, I could move the 1/2 up front, and that would make it log base 2 of 8x over x plus 1. That's 1/2, and I'll open parentheses, log base 2. So whatever's at the top, you add. Whatever's in the denominator, you subtract. And isn't 8 really 2 cubed? So wouldn't that be 1/2 3 plus log base 2 of x minus log base 2 of x plus 1? Be careful, we have no rule for a plus. You could distribute that 1/2 in. You could leave it as is. It really makes no difference. And if I want to apply that analogy to this problem, I'll say, look, this is the log. The base is 10 since they didn't put a base, of a squared plus the log of cube root of bc. This is, by the third law, twice log of a. That's done. I'm going to have to write the bc as a 1/3 power. I can move that power up front. And last thing I have to do is say that's 1/3 times log of two things multiplied. Isn't that the log of b plus the log of c? You could distribute the 1/2 in. You could leave it as is. That makes no difference. Here, I notice there's division. So I'm going to say this is the log of the square root of d minus 5 minus the log of b to the 4th minus the log of c. You could do that in 2 steps. You could do it in 1 step. That's the log of d minus 5 to the 1/2. I can move that up front. And if I move this up front, pretty much I'm done. Now I am going to add, I said you could leave it as is or you could expand it a bit. I am going to expand it a bit, just to make sure when you look at the back of the book, you're getting the same answer. So you could write 3/2 if you distribute the 1/2 in. Again, you don't have to, I really don't mind, but I think the book does. And of course, the fun back is going back. So going down and going back up. And this will be twice the log, the log of a, look at that. Plus distribute the 1/3 in, 1/3 log of b plus 1/3 log of c. And that would be this problem. And here it is, going backwards. Combine into a single log. To combine into a single log, I need this to be a 1 or a negative 1. So by the third law, I reverse the law. Remember, this is going to belong to the entire argument. Argument is what you're taking the log of. So this is going to be log base a of 5x cubed squared minus log base a of 2x plus 3 to the 1/2. This is going to be 2 logs with a minus in between. Now that there's a 1, I could write that as a single log base a, and the division will be where the minus is. The top is 25x to the 6, and the denominator, isn't that the square root of 2x plus 3? And that takes care of it. And if I look at this problem, again the same deal. The first order of business is making sure that's a 1. It's not easy fix. Remember, that's the power. And easy fix, that is the log of 3p squared to the 4th minus the log of 8 minus 3x to the 1/5. Again, 2 logs with a minus in between. The minus really turns into division. The base here is a 10 because it doesn't write anything. And it's going to be this. 3 to the 4th is 81p to the 8. And 1/5 power is really the 5th root of 8 minus 3x. Kind of messy, but once you get the hang of it, it's really a lot simpler than you think. Make sure it applies to the whole argument. So this is the log base 3 of 4w to the 5th minus the log base 3 of 5y cubed. Again, the reason you do that, if you look at the laws of logs, they only consist of a 1 or a -1, which is exactly what I did. And if I do this correctly, I should be able to do it in one step. The division will be wherever the minus is, and the top will be whatever's plus. This is positive. That is 4 to the 5th. What is that? 16 times 16. Oh, for 16 times 16, 256. 256 times 4, 1024 w to the 5th. Since that's a minus, that's going to go in the denominator. That would be 125y cubed. Since that's a plus, that's going to be x squared. And there it is, one shot. You don't have to do it one shot, but I suggest you practice until you get there. Now we have this most important formula. There's only one formula, and that is the change of base. What if the base is not something we like? If you see a log with a base that you do not like, you could write that as a log of your choice of base, meaning you could write log base b of x as ln of x over ln of b, or log of x over log of b. The reason we're choosing ln and log, because that's what your calculator can read. So in this case, we need a calculator. If I look at a base that I don't have, my calculator cannot read log base 12. So I could say that's natural log of whatever the argument is based on that formula, divided by natural log of 12. And what's the benefit from that? I could open my calculator out, and a log with a natural base is right there, and a log with a base 10 is right there. So if I take parentheses natural log of 7 divided by 8 divided by natural log of 12, oops, too many, here we go. I'll get a negative 0. I forgot to copy directions. And here we are. Use the change of base formula to find the value approximate to the nearest 100. And if I get, oops, wrong calculator. If I get my calculator out, to the nearest 100, negative 0.5 will do. Here, again, the base is not. Again, I have an option. Either I use a log base n or a log base. Alright, so one of those two. And I'm going to use a log in this case. Basically, we're going to say this is the log of the argument. You can't change the order. Divided by the log of 8, which is what this says. If you notice, the argument x is at the top. There's the argument is at the top. The base, I'm choosing a base of 10. So in this case, I will say this is, and if I get my calculator out, and if I take parentheses log of 25 divided by 7 divided by log of 8, I'll get 0.61. 0.61. Now, just to demonstrate, I could have said, let's take natural log of 25 divided by 7 divided by natural log of... As long as the base is the same, you get the same answer. You can't get it wrong. And if I look at number 54, the same deal. I like natural log because it's one letter shorter. Nothing more. And if I plug this in my calculator, if I take the natural log of 38 divided by 3 divided by natural log of 5, I'll get 1.58. 1.58. All of these numbers are irrational. And if I do the last problem, I don't like that base. But, so, if you didn't recognize what this problem is, and you said, you know what, I'm going to use that base. If you didn't see that's a 1, and that's automatically 5 times 0, which is 0, you're done. Isn't that natural log of 1 divided by natural log of 3? And if I use my calculator, guess what? If I take 5 times natural log of 1 divided by natural log of 3, I'll get a 0 there. No big deal. Alright? And the homework is right here.